There are at least 100 billion galaxies in the universe according to the data from the Hubble Space Telescope, but we're still so far away from understanding even our own. While it's only an average-sized galaxy, the Milky Way contains billions of stars and billions more planets, all orbiting a supermassive black hole. But will we ever get to see all of the arms of this spectacular spiral? This is Unveiled, and today we're answering the extraordinary question, how long would it take to travel the Milky Way? Are you a fiend for facts? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more fascinating content. Since all objects in space are moving all the time, we're actually traveling across the Milky Way right now. Earth may be orbiting the Sun at 67,000 miles per hour, but the solar system is orbiting the galactic center at an even more mind-boggling speed of 500,000 miles per hour. At this speed, it takes us roughly 230 million years to complete a full lap of our spiral galaxy, which is otherwise known as a cosmic year. It takes so long that the Earth, being approximately 4.5 billion years old, has only completed 19, possibly 20 full circuits of the Milky Way in its history. And since our planet is already halfway through its expected lifespan, it's only got time left to do the same number again. The Milky Way has a diameter of at least 105,000 light-years. Since a light-year is 5.88 trillion miles in length, this makes the Milky Way more than 600 quadrillion miles from one end to the other, though this is actually a conservative estimate. Other studies have suggested that the Milky Way's disk might reach as far as 200,000 light-years, as stars orbiting the galactic center have been found much further out than we previously believed was possible. This means that it would take a photon traveling at the speed of light up to 200,000 years to cross the Milky Way, depending on where you draw the boundary. Humans, though, unlike photons, can't travel at the speed of light. And even if we could, while 200,000 years isn't all that much in the general history of space, it certainly is for us. Modern humans only evolved between 200,000 and 300,000 years ago, so by the time you'd have completed your impossible but hypothetical circuit of the Milky Way at light speed, you'd still have been gone for as long as it previously took the humans you left behind to evolve into themselves. By the time you returned, if humans were still living on Earth, then they could well be totally unrecognizable to you. But seeing as humans can't travel and likely never will be able to travel at the speed of light, what are our options if we were to set off on this journey today? Well, the most common mode of transport on Earth is cars, with now more than 1 billion cars on roads all across the planet. Obviously, cars as they are don't fly, but say they could. If you drove one at a leisurely, consistent speed of 60 miles per hour, it would take you 2 trillion years to cross the Milky Way galaxy. It's lucky then that we have some much faster vehicles at our disposal for space travel. The Voyager space probes travel through space at around 35,000 miles per hour, a much more impressive rate which would reduce our journey time, but still only to about 2 billion years. So could we do even better? Well, the Juno space probe reached 165,000 miles per hour at its peak in 2016. The catch being that Juno could only get to this velocity while it was also being pulled in by the gravity of Jupiter. But if we could somehow maintain this speed, then crossing the galaxy should now take roughly 400 million years only. And then there's the Parker Solar Probe, NASA's groundbreaking mission to the Sun, which it's thought could tip 430,000 miles per hour by the time its journey is complete. An incredible speed which, if it were possible to maintain, would ask of us a mere 150 million years to complete our trip, a considerably more efficient commute than our hypothetically flying car. Practically speaking, though, there are plenty of problems with using speeds achieved by space probes for this particular thought experiment. Not least that space probes aren't anywhere near big or safe enough to house humans, which somewhat limits the methods we can even feasibly use for long-haul space travel. So how do we get around it? Generation ships are currently seen as one of our best options for seeing the entirety of the Milky Way up close. A huge arc capable of sustaining thousands of people could theoretically drift through the galaxy with the aim of exploring and cataloging everything in it. Generation ships don't shy away from the issue of humans living short lives either, instead operating on the fact that everybody on board will grow old and die. Many generations would come and go without ever seeing a new planet or star, but they'd still have a better chance of doing so than anyone left behind on Earth. With every mile they moved away from Earth, they'd be a mile further into totally uncharted territory. But again, the extremely gradual journey would also take far longer than the time humans have already been alive for, so there's no telling how our species will have changed after centuries spent cooped up inside the same spaceship. By the time they reached their destination, they and the humans they had left behind on Earth could even have taken totally different evolutionary paths, becoming unrecognizable to each other were they to one day somehow meet. Going one step even further, those on board the Generation ship and those left on Earth might even have forgotten about each other over time, so if there ever was a meeting, neither side would know the significance of it. But maybe there's another way. A way for the same people as started the journey to see the Milky Way without leaving it in the hands of their descendants thousands of years down the line. As a sci-fi favorite, putting humans into hibernation is probably one of the most popular suggestions for how we could make sure astronauts survive long journeys. In the real world, it has been proposed for all sorts of missions, be it comparatively short trips to Mars or genuine deep space travel much further afield. In theory, hypersleep, or suspended animation, would mean that Earth could send a smaller crew in a smaller and faster vehicle than a gargantuan Generation ship, only waking them up from hibernation precisely when there was actually something interesting to look at. Unfortunately, hypersleep is much more science fiction than science fact at the moment, but that doesn't mean we aren't trying to come up with solutions like it. Exactly how any crew on board would decide what was and wasn't worthy of stopping for would be another problem entirely. On a journey across the Milky Way, we would, after all, have an entire galaxy's worth of stuff to consider. Would we want to stop and examine every single planet, every alien solar system, every black hole? Even forgetting the mammoth transit times it would take to get to anywhere else for a moment, the Milky Way contains at least 100 billion planets. If you were to spend a day on every single one, that's 100 billion days, which is over 250 million years in itself. Shave that figure down so that we only pay visit to potentially habitable, possibly Earth-like planets, and the number is still huge, with at least 11 billion but perhaps more than 40 billion qualifying worlds out there. So that's a minimum of 30 million years. Humans live for 72 years on average, and the average age of an astronaut candidate before training in the US is 34. If every astronaut worked until they died, they might enjoy an average of around 35 years in which to explore, or 12,775 days. In a hypothetical time when visiting a planet, or moon, or any other kind of object a day was possible, which obviously it very definitely isn't right now, that means just 12,775 pit stops per human lifetime, which is barely scratching even the surface of the surface when it comes to the Milky Way. Ultimately, even traveling as fast as it's physically possible for matter to go, this particular journey would still take up to 200,000 years to complete. It would take far longer than a single human lifespan even if you were moving at 10 times the speed of light. So maybe the best way of exploring our galaxy in its full and fantastic entirety really is by simply looking into the night sky, because that's how long it takes to travel the Milky Way. What do you think? Is there anything we missed? Let us know in the comments, check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.